Hello everyone, this is Amir from Audio Science Review. If you watched my last video on the AudioQuest Niagara 1200 AC conditioner, I promised a more generic approach to figuring out if noise and distortion in AC line impacts the fidelity of our audio equipment. I wanted to do this project probably 3 or 4 years ago and went out and bought a bunch of equipment to do it, and just been busy ever since, and have not used I haven't tried to run this project, and the results even surprised me a bit, but it's very unique work, and I don't think anybody else has done this. So the heart of the system is this B&K Precision 9801. It's about a $2,200 device. It's very heavy and massive. It's actually sitting there. It's about this deep, and it's got a noisy fan. What it does is that it takes the AC from your mains outlet, converts it to DC, and then regenerates it using microprocessor control. Very accurate AC waveform that comes out of it. It goes up to 300 volt amps, which is roughly equivalent to watts, not quite 300 watts. So it's not suitable for powering large devices, but certainly good enough to power a lot of source devices, DACs, and headphone amps and preamplifiers and so forth. Parallel to that, there's another box in there from a company, PS Audio. They built this 20, 30 years ago and built quite a fame. It's at the P300. It's also a massive box this big, and it's all heatsink. It's just a giant hunk of aluminum and heavy, and it's about 500 watts. The reason it's very heavy is because it doesn't have fan. Unlike my fancy instruments, you can only change the frequency. With my instrument, I can change the voltage, change the frequency, and make a bunch of other cool measurements like power factor and other things. But it also produces, AC using similar scheme that I talked about. I've gotten a lot of requests on whether these things work. So in this article, I'll also show you measurements of that device and quantify what it does. But anyway, the goal is to see what the impact of AC noise and distortion is on audio equipment. And so far I've done this by measuring power cords and measuring AC conditioners, and in every case found zero difference. And as you'll see in a second, I'm able to do something with this B&K Precision 9801 that I can't do with other devices, in that I can turn the tables around and actually generate, far more noise distortion, and then we can see if there's an impact on our devices or not. But first, let's get familiar with a little bit of the instrumentation and what we're doing. This is the AC mains measurements using a specialized probe where I literally hook up 2 wires to the AC mains, and I divide it down by 100, this device does, so that what comes out of it is only 1.1 volts instead of 118 volts. And that makes it safe to then feed the output to my audio precision analyzer and not blow it up. So please don't do this test unless you know what you're doing. The probe is also differential in nature. What that means is that any noise that lands on it, if it's the same on both cables, it doesn't get amplified. And that's important because in our environment, there's other sources of AC noise and what have you. And you want to really measure the device you're measuring as opposed to what could radiate onto it. So it does that also for us, which is very nice. And my audio precision is differential input, and so it all matches and works really well. As I've shown before in my previous reviews, AC, as it's fed to my house, has a fair amount of distortion. And this is probably the norm, or maybe a little cleaner. You could get worse than this. I doubt that you can get much cleaner than this. But at any rate, the power company doesn't owe you clean power. It's a miracle that it gives you something that looks like a sine wave on this thing. But it's got enough harmonic and distortion and noise to actually be something we can measure, THT plus N, just like we measure an amplifier, we can measure our AC mains. It thinks it's got about 1.9% worth of distortion and noise, and if we convert that to SINAT, it's about 34 dB. You can see the frequency 60 hertz plus a little fraction. So it's amazing that power can be distributed with such high accuracy all the way out here. So let's now measure the what comes out of the PS Audio P300. Let me see if I can just get this to scroll a little bit. Yeah. And now look at what happens. First of all, a waveform is very smooth and clean. We no longer can see any distortion by just looking at the time domain scope output. The reason for that is that we see our main power spike over here, but now look at the distortion, harmonic distortion and noise. It's far lower. And to the tune of, we go from 1.9% to just 0.08%, so quite a bit lower distortion and noise. And if we convert that to sine out, that's about 61 dB. So essentially, this is power amplifiers, what these things are, high voltage power amplifiers, but 60 hertz is something that's in your music, and that's what your amplifier actually does, converts AC to DC, and then amplifies whatever frequency you give them. These things are a little bit more specialized, but essentially this is like an amplifier that has a sine out of 61 dB. If I then measure the same thing, but this time with my BK Precision 9801 lab AC generator, I see a very similar result. This time to get a little bit more accuracy in my frequency and voltage, but that's not critical. THD plus noise actually drops to 0.05% from previous 0.08%. So it's, as a spectrum, it's cleaner spectrum, and sine out is about 64 dB. That said, that's because it has less harmonic distortion, but it actually has a little bit more rising noise in here in the, where it could be audibly more concerning. But really the two are one and the same. For the rest of these tests, I chose to no longer use the P300 from PS Audio. It's basically what my lab generator does, and then my lab generator has a trick up his sleeve that this one doesn't, and you'll see that in a second. But as a statement on what P300 does, it produces clean AC power. So regenerators do regenerate AC mains, and because they do it under their control like a power amplifier would, they naturally can have much better fidelity than your power company miles and miles and miles away sending you power. So let's get to the neat trick that my device can do, my lab AC generator can do. For testing purposes, it can simulate what a dimmer output would look like. The way dimmers typically work is that you have that go down here. We have our sine wave in here that would normally go into a light bulb, and the light bulb converts all this to heat and light energy. What they do is that they let the sine wave go on, and then at a certain point they truncate, they stop conducting, and they do it on each cycle. So you can program, depending on where you set the dimmer, you can program how much of that waveform is left alone, what part of it is chopped off. And you can see it in here. And this is programmable in the 9801. I just set it to a random 35 degrees. So 35 out of 360 degrees is set to have no output, and that's what this flattened section is. We see the waveform is somewhat deformed also, so its emulation is not perfect. But in this case, we want dirty power, and the dirtier the better. So there's a little bit of a step response and deformity over here produce incredible amount of AC mains distortion. Our THD plus N now is shot up to 18%, so way above our 1.8%, and our sine out has dropped to just 15 dB. So clearly we have boatload of noise and distortion now pumping out of the AC output of this generator. So the question now is, can this make an impact on our audio devices? Because now we've exaggerated it a lot. So before, if the effect was tiny, maybe we couldn't measure it. But now that we've hugely magnified the problem to a point where nobody has a power distribution has this kind of distortion at all, and yet we want to feed that into our audio equipment and see what happens. Do they survive it? Do they produce garbage? Do they do a good job? So I start again with, sorry, let me scroll back up. Okay. I start with my topping A90 preamplifier and feed it 4 volts, and 4 volts comes out, and measure noise and distortion, and it, as usual, produces extremely low noise and distortion, well below threshold of hearing. It's extremely clean by itself, as I've shown before, and that's a sign of a well-designed device. First, I hook it up to the B&K Precision with its much cleaner output. So I haven't used a dimmer mode yet. Remember, the output of this B&K Precision is much cleaner than my mains power. Excuse me. And we see that there's no impact whatsoever. Whatever we saw, 117 dB SINAD, 117 dB SINAD. So going to the positive side, filtering more didn't do us any good. The device is just as good. And we've seen this before where I've, taken other devices to do AC mains filtering and shown that they make no difference. But now we can go the other direction and feed that horrendous AC mains, this heavily distorted AC waveform with all these harmonics and noise. Let's feed that to it and see whether it complains. Not only does it not complain, nothing changes in it. Not one hair is out of place. SINAD is still 117 dB and change. Same output, same everything. This device does not care what you've done to it. And naturally so. I'll explain a little bit more why it doesn't care. But basically, we see that there's no impact whatsoever. So it doesn't care if you make the AC cleaner or if you make it tons noisier and more distorted. It doesn't care. Now, when I do these things, sometimes people come back and say, well, how about, you test with a lousy device? Which is a weird question, because why would you get a lousy device and then go spend $1,000 or more on a conditioner, take that money and buy a better device? But anyway, I went looking around for a lousy device, and being who I am and the kind of products I get that usually I either buy or to test, I don't have a lot of lousy products. 99% of what I have is extremely good. But I had bought this DAC from, I shouldn't say I bought it. I bid on it at our Audiophile Society. We had an auction to fund the activities of Audiophile Society. And a member had donated this DAC. It's called the Sigma DAC, California Audio Labs. It actually has a tube in the back. And I hadn't tested it since I bought it about a year ago. And so I thought, well, I'll pull it up and, likely has poor performance. And actually not too bad. I hooked it up with my generic AC mains and it has a SINAD of 81. State of the art is 120, 123 dB, so it's not state of the art, obviously. We would give it a very poor rating now, but certainly not broken. 81 dB, quite respectable. I then fed it a very clean AC source instead of the straight, mains input, and it made no difference. Why? Because the problem is in harmonic distortion that is generating up here. It has nothing to do with mains, and whatever problems it has in mains didn't improve. These are power supply issues that it has, and it has them whether you clean them up or not is sort of internal problem to design. So it made no difference whatsoever. At this point, I was going to turn on that dimmer emulation in my lab generator. But as soon as I wanted to go do that, this thing started to do crazy things where the noise floor started to fly up and down by itself. And the SINAD was just jumping from 30, 40 up to 80 and then back down. I didn't have time to fix it. So I, by the way, was doing that on any AC power. I went back to the mains one. It made no difference. Just decided that it was time for it to not work. I don't know if the tube's gone bad in there or capacitors or something. But anyway, desperate, I went walking around to see if I have anything else. And I had this Luxg P20 headphone amplifier. It's got a couple of tubes on it, cute little thing. I had bought this 1.5 to 2 years ago to test, and I had not unpacked it. So I decided, hey, why don't we unpack it and, test this one with it. So once again, we start with the generic AC, and we see that, yep, it has a lot of mains hum coming in, but its real problem are these massive harmonic distortion spikes that are, bringing the SINAD down to 66 dB or so. So it's this thing's definitely low performance. So we're talking 66 dB versus 120 dB in my other device. And I hook it up to the cleaner source of 9801. And does it do anything? Not a single thing. 66 dB before, 66, 67 dB now. Absolutely makes no difference. No improvements whatsoever. Could not use the help. But let's go in reverse. Let's pump that distorted dimmer waveform AC into it and see what happens. Once again, no change whatsoever. The dirtiest AC feed you could ever think of. I'm pumping into this device. It doesn't care. Why don't these things care? I mean, intuitively you think the nicer the ingredients that go in a dish, the better it should taste. And if you clean up the AC, surely that contributes. The reason they don't care is because these devices operate on DC, which means the first thing they do is rectify the AC and filter it to get DC. And that act of converting and rectifying things to DC, by definition, means you're getting rid of AC components. So the wiggliness of this dimmer, waveform is all gone. It's DC, if you look at it, it's basically a line. Yes, it'll have some low-level noise in it and ripple and what have you, and that's what's showing up in here. But that's basically due to the design of the device, excuse me. Shouldn't have drank Coke before doing the video. At any rate, so when you convert things to DC, these problems just naturally filter away. We're not experiencing the AC mains. We're experiencing it after it's been converted to DC, and that DC then powers the circuit. And by the way, a lot of circuits have feedback and other mechanism in them that makes them reject power supply noise. And when you're sort of at the wrong end of this trying to optimize things, you're just not able to cause any change downstream. So we have a very unique set of results over here in that we went all out, produced the world's dirtiest, most miserable waveform, and it made no difference. So if that can't make a difference, certainly shaving off a little bit of distortion and noise from your AC mains is not going to do anything. And by the way, the only thing that can shave off properly those distortion and noise are these regenerators, which are extremely inefficient, suck up a ton of power, but there's just no reason to use them. I use mine as an instrument to troubleshoot things, but even though I have both of them, they're never powered on, hooked up to any audio equipment that I use. So, we could be testing 1,000 other devices, and maybe one or two of them will make a difference, but that's not the point. If these things wanted to make a difference, when I made the AC so much worse, one of these three should have done something, should have shown at least 1% change. We don't even have 0.01% change. It's just the devices don't care. They shouldn't care, thankfully. No engineer designs a piece of audio equipment thinking, hey, I'm going to have clean AC power to feed them. No, we're not going to want to, feed clean, we don't have clean AC. By definition, we assume that it's not clean, and we filter and clean it up. One note, if you go to the thread in here, quickly got a secondary branch where a lot of people try to defend boxes that clean up AC for other reasons. They said, well, if you have real noise that's causing glitches and pops and hum or whatever physically on a transformer or in the output of your machine, such devices may do some good. Fine, but I don't see people buying audio purpose, mains, recondition, regenerators for that reason. Just about everybody buys them because they think they'll take the fidelity of their system from here to there. And I'm here to tell you, you go from here to the same place. All that happens is that your bank account goes down, you're wasting more power, more stuff sitting in between. And by the way, anytime you have another box with another power supply, you could create more ground loops. It's just the way the laws in electronics work. So don't assume that just adding these things that can have no negative consequence, they could have negative consequence. So if you know what you're doing and you have some real mains issues, sure, analyze it, understand it, go get whatever. I'm strictly addressing fidelity improvements, and tons of companies now go sell these products to make your audio equipment sound better. And I'm here to tell you that I can't find any evidence that they do anything, and devices, according to both engineering, measurements, and everything we know, there's no there on these devices. So hopefully you found this useful, and I'll see you in a future video. Bye-bye.